All right, let's go through some of those problems together. So the first one is just to tell whether the function is, the inverse would be a function or not, whether it's 1 or 1 to 1. So in problem number 3, the answer would be no, because if I flip these around, then in this case I would be plugging in 2 and getting 2 as an answer. In this case I would be plugging in 2 and getting 6 as an answer. So these two things sort of contradict each other, and so that means that the inverse would not be a function, which means that the original function is not 1 to 1. In this case, however, since I never got the same y value originally, I'm never going to, when I turn those into inputs, get two different things when I plug those in. So this function would, in fact, be 1 to 1. Okay? Load on, okay. Okay, hopefully you can see very quickly that this one is 1 to 1. Because it passes the vertical line test, so that means it's a function, and it passes the horizontal line test, so that means its inverse is a function. All right. This guy right here is not 1 to 1 because it fails the the horizontal line test in this region right here. Anywhere here where I drew horizontal line is going to cross that original graph more than once, so the inverse will not be a function. Okay. This one is also not 1 to 1, and that is because, same reason, in this area right up here, if I draw a horizontal line, it's going to cross the graph more than once, so the inverse will not be a function. Okay, drew that by hand. Pretty fancy stuff. That you didn't notice that. Probably thought just copied and pasted that right out of the text. That one is 1 to 1 because it passes both the horizontal and the vertical line test. Okay. Okay, this one, if we look at it, as soon as you see this x squared thing in there, then you should recognize that the graph of that is going to be a parabola. And I am here to tell you that no parabolas in the world are one-to-one functions, because anytime you have a U-shaped graph, it's going to fail the horizontal line test, so it will not be one-to-one. Okay. This one is easy peasy. This one is 1 to 1 because if I graphed this, I would just get an old-fashioned linear graph, 10 minus 3x, like that, which would pass the vertical and the horizontal line test. 1 over x, that graph may not be really obvious to you, but it should be. 1 over x is going to look like this, and it's going to look like this. And so that one is going to be 1 to 1. And something interesting about that is that this function is its own inverse. If I flip this over the line y equals x, it would just be right on top of itself. So the inverse of 1 over x is 1 over x, and the inverse of that is 1 over x, and the inverse of that is, okay, that's that. Okay, absolute value of x, you know that that's a V-shaped graph, so that is going to fail the horizontal line test miserably. So that is not 1 to 1. If you think about the function itself, that is because if I plug in 2, I get 2 as an answer. If I plug in negative 2, I also get 2 as an answer. So for the inverse, if I plug in 2, I would either get negative 2 or 2 different outputs. Not okay. Okay, 1 plus cosine of x. If you think about the cosine graph, you know that it looks something like that. And as soon as you see something like that, then you know that this function is not 1 to 1 either, because it fills the horizontal line test everywhere. So that's no good. What about 1 plus cosine if we restrict the x value only to 0 to pi? Well, gosh, that's an interesting question. Let's take a look. So if I do 1 plus cosine, let's do regular old cosine first. That crosses the y-axis, x-axis, sorry, at pi over 2, and then bottoms out at pi. if I take 1 plus that, that would just move it up 1. I guess I should bottom out at that point on the graph. Okay, so this one, if we restrict the domain to just between 0 and pi, then this one would be 1 to 1, because we have eliminated the places where the graph would fail the horizontal line test. And that is something we're going to talk about more when we get into inverse trig functions. All right, height of a football, t seconds after kickoff. You know that is roughly parabolic. And as we said before, there's a lot of different places where this would fail the vertical line test. And so that one would not be 1 to 1. How about your height at any age? Well, we could have a robust discussion about that, I'm sure, if we were together in the classroom. Really, technically, the answer to this is going to be no, because you start at a certain age or height when you're born, and you grow and you grow and you grow, and then, of course, you level off, and at some point you do start to shrink a little bit. And so, as long as you, make it that long, then there's going to be a time in your life, or 2 different times in your life, where you were the same height. Well, I guess it doesn't even need to. You don't even need to shrink. Just as soon as you stop growing, then this would be a horizontal line, and then, yeah, it'll pass or fail the horizontal line test. So as long as you live long enough to stop growing, then that function is not going to be 1 to 1. Okay, let's do some simple inverse mechanics here. If f is a 1-to-1 function such that f of 2 is equal to 9, what is f inverse of 9? Well, f inverse of 9 would be 2. And that's because when you plugged in 2 to the original function, you got 9 as an answer. So that means when you plug 9 into the inverse function, you should get 2 as an answer. All right, this one is a little bit trickier because we can't algebraically find the inverse function for x plus cosine of x. So we have to figure out what value of x would we need to plug in to the function to get 1 as an answer. So if f of x equals 1, what is x is what we're trying to figure out. And so this is a little bit of a guess and check, but hopefully you can see that f of 0 is going to be 0 plus cosine of 0, which is 1. So that means f of 0 equals 1. So that means f inverse of 1 is equal to 0. Okay? And so that's a little bit of a dirty trick because we're just kind of guessing checking, and we don't really usually like to do that in math, but sometimes you have to. So here's that same sort of idea again. We're trying to find h inverse of 6. So what we're really being asked here is if h of x equals 6, what is x? In other words, what value of x do I need to plug in to this to get 6 as an answer? And so just sort of trying some different ideas in my head. H of 4 would be 4 plus, is it really worth it? Yeah, why not? I've got lots of time after all. So that would be 4 plus the square root of 4. And since the, I have to learn how to change that color so it matches. Since the square root of 4 is 2, this would be 4 plus 2, which is 6. So 4 is the value that we were looking for. these are the droids we were looking for. So h inverse of 6 equals 4. H of 4 equals 6. H inverse of 6 equals 4. Okay. Alright, are we doing this one? Yeah, number 20. Okay, the graph is given. Why is this graph 1 to 1? Passes horizontal line test. What is the domain and range of the inverse? Well, let's see. If we're ending right there, the domain, let's talk about the domain and range of the original function first. So the domain of f is from negative 3 to 3. And the range of f of x is the y values, so that's from negative 1 to 3. Okay, so that means if I want to do the inverse of x, we would just switch the domain and range. So the domain would be what the range of the original function was, negative 1 to 3. And the range of the inverse would be the domain of the original function, which is negative 3 to 3. Okay, what is the value of f inverse of 2? In other words, what value of x do I need to plug into the original function to get 2 as an answer? If I go up here to the graph, then it looks to me as though f of, I hate it when it does this, f of 0 equals 2, so that means f inverse of 2 equals 0. Estimate the value of f inverse of 0. That's estimate because that's this point over here. So I'm going to say that f of negative 1.75 is equal to 0. So that means f inverse of 0 equals about negative 1.75. Okay, 23 through 28. Oh, okay. So for these problems, we're asked to actually find the inverse. Okay, so first step is switch the x and the y. So rewrite it as x equals 3 minus 2y. To solve that for y, so I'm going to say negative 2y is equal to x minus 3. And then I need to divide everything by negative 2. So x minus 3 divided by negative 2 is the inverse. Okay, oh, this is going to be a tougher one to find the inverse of. Steps are still the same. X equals 4y minus 1 divided by 2x plus 3. This is indeed a fraction. Whoops, and this should be a y, of course. Okay, so then my next step is to cross multiply to get rid of the fraction. So if I multiply this by that, then I get 2xy plus 3x equals 4y minus 1. Then, since I'm trying to solve for y, I'm going to get all the terms with y's in them on the same side. So 2xy minus 4y equals, we get everything without a y in it on the opposite side, negative 3x minus 1. And then here's the trick to these problems is now to solve for y, you need to factor a y out of both of these terms. So if I factor a y out of 2xy, that leaves me with 2x. If I factor a y out of 4y, that leaves me with 4. That still equals negative 3x minus 1. And then my final step is to divide both sides by 2x minus 4 to get the y by itself. So that gives me an answer of, final answer, negative 3x minus 1 divided by 2x minus 4. Okay. Also, just so you know, we could have done this by from this step here. You could have chosen to put all the y's on this side and all the x's on the other side, and in that case we would have gotten the same answer, but all of the signs would have been switched. So you could also say 3x plus 1 divided by negative 2x plus 4, if you were so inclined. Okay. On to 28, huh? All right, I got that. Okay, next one. Switch the x and the y. So this is going to be square root of 10 minus 3y. Okay. Oh, that showed up right in the right place. Okay, so then my first step to get the y by itself is to square both sides. So x squared equals 10 minus 3y. And I'm going to subtract 10 from both sides. So 3y equals x squared minus 10. I'm going to divide everybody by negative 3. So x squared minus 10 is now divided by negative 3. And that's it. That is my inverse. Okay. Alright, 26. Now we got ourselves a cube root. So I have to go x equals 2y cubed plus 3. So x minus 3 equals 2y cubed. So 2y cubed equals x minus 3. Then divide both sides by 2. And then I have to cube root both sides. So that would be y equals I should probably pause the video when I do this. You guys don't see the wizard behind the curtain. Just boom, show up as the answer. So that would be the cube root of x minus 3 divided by 2. I think I can just make that kind of matches. Alright, 27, I'm losing interest. You probably have a long time ago. Let's change colors and see if that'll spice things up a little bit. So x equals 1 minus the square root of y. Let me get another square root of y going while I'm at it. Okay, so this is going to be 1 minus the square root of y. And then down here I'm going to have, this is awkward, 1 plus the square root of y, and then don't forget that these are fracciones. Alright, so next step seems like I should probably cross multiply. So let me get a couple more of these, I'm going to need them. Okay, so if I cross multiply, then I would have x times 1 plus the square root of y. Equals, on this side, 1 minus square root of y. Okay. Alright, I feel like I'm going to, not really sure where I'm headed here. I hope this works out. I'm going to distribute the x. So x plus x root y. Duplicate this bad boy. X plus x root y equals 1 minus, what was that, control D, square root of y. Okay, everybody with a y in it, I'm going to put on the left. So that means on the left I'm going to have x. So I'm going to need a couple of those for this step. So x root y plus root y. Wow, hard to imagine this being more awkward than it is. Okay, so that's this x root y, and then I added the square root of y, and then at the same time I have to subtract this x over to there. So that's equals to 1 minus x. Okay. All right, now I'm going to, we're getting closer, I'm going to factor out a square root of y. So that would leave me x plus 1, if I factor that out of both of those, equals 1 minus x. Then I am going to divide both sides by x plus 1. So that means we pretty much got her here. So the square root of y equals 1 minus x divided by x plus 1. But that's the square root of y, so if I want to figure out as my final answer what y actually equals, it would be all of this stuff squared. That is awkward, but there she is, final answer. Way to stick with it. Alright, I had enough of that. Well, no, let's see, there's some good algebra tricks in here. You guys aren't going to watch this anyway, so I'm just entertaining myself here. So x equals, in this case, 2y squared minus 8y. I've got to try and solve that for y. So I'm going to factor the right-hand side. I'm going to factor a 2y out of there, which is going to leave me, I don't know where this is going to end up. Y minus 4. Is that really what I wanted to do? I thought I was going to get like a, ouch, perfect square going here. Yeah, not clear on that one. Yeah, because I somehow need to separate those terms. I wonder if I have to complete the square. Let's try that. Let's go back up to the beginning and go x equals 2y squared minus 8y. And okay, I want a new text box. Let's instead of factoring out the 2y, let's just factor out a 2. So that would leave me with y squared minus 4y. I remember going through completing the square last year or the year before. And, oh man, Ben Ryer was so mad. Okay, so if I complete the square, half of this is 2, and 2 squared is 4, so I'm going to add 4 there. But then I need to compensate for that by adding 8 onto this side. Why did I add 8 onto this side and not just 4? Because I added 4 inside parentheses. There's 2 outside the parentheses, multiplied the 4 and made it an 8. So I was really adding 8. Yeah, this is what I should have done. So this work over here is, well, whatever. Ignore my first attempt. Okay. So now if I divide both sides by 2, that gives me y squared minus 4y plus 4 equals x plus 8 divided by 2. And now we're in business because I can take this and factor it into 1 minus 2 quantity squared equals x plus 8 divided by 2. Then I square root both sides. I do not want to use that. Well, I guess I'm going to have to. So y minus 2 equals the square root of it is the square root of x plus 8 divided by 2. I don't like how that always comes out a little bit bigger. And I don't like that it comes out to be a different color. So then if I take this minus 2 and add that onto the other side, my final answer is we're having a quality day today, kids. We're making sure that we're really doing our best work. Y equals square root of x plus 8 plus 2. Okay, so there we go. All right, only through 28. Okay, and then 31 and 32, and we will wrap her up. Oh, that's 30 still. Okay, so 31 and 32, yeah, these, I didn't cut and paste these into the flip chart for some reason, so they're a little bit hard to do. I'm just going to take the x and the y values and reflect them. So I think that this was, dude, I don't know, this is 1, negative 1. So if I flip that, I get negative 1, 1. So I have a point right there. I'm pretty sure this was 2, 2, so if I reflect that, I get 2, 2. This was 3, 3. Oh yeah, because those are right on the line, y equals x. And then what do you want to call this? Negative 1, negative 2. So that would switch to be negative 2, negative 1. And then my function would look like this. Oh, how could I miss that? Try that again. As you can see, is roughly a reflection over the line y equals x. Okay, then last one, if I am at the point 0, 1, that gets reflected to the point 1, 0. The point right here at 2, 0 gets reflected to the point 0, 2. And then I don't know what this is, probably 3, negative 1 gets reflected to negative 1, 3. And so in this case, our inverse function would look like that. And again, hopefully you can kind of visualize that that is a reflection. Totally nailed that. Good way to end the day. Over the line, y equals x. All right, as always, stay in touch if you need help with anything, if you want me to do anything different. Just do math, man, just to keep your brain active and stop staring at your phone all day. You know, it's good for you. All right, talk to you guys tomorrow.